Hello, and welcome to Streaming Data Processing with Amazon Kinesis and AWS Lambda webinar. My name is Vyom Nagrani. I will be your presenter for today. Here we have with us Ajay Nair, who is a Senior Product Manager from AWS. Ajay will be our Q&A moderator for today. A little background about myself. I am a Senior Product Manager for AWS Lambda, a compute service that runs your code in response to events and automatically manages the compute resources for you. Lambda helps developers think about applications in a new way by creating simple event handlers that respond to updates from Amazon S3, Amazon DynamoDB, Amazon Kinesis, Amazon SNS, and other services, as well as directly from web and mobile applications. I hold an MBA from the University of Michigan and have previous experience across product management, product marketing, and product engineering. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A panel. Please submit your questions at any time during this webinar. Ajay will answer as many questions as time allows in the Q&A panel while I am presenting. Towards the end of the webinar, there will be a live Q&A session and I will address some questions as well. Lastly, this webinar is being recorded. We will share the recording and the presentation slides via email to all of you a few days after the webinar. So let's start off by a brief overview of what both of these services are. Amazon Kinesis is a fully managed, cloud-based service for real-time data processing over large distributed data systems. Kinesis can continuously capture and store terabytes of data per hour from hundreds of thousands of sources. With Amazon's Kinesis client library, you can build Kinesis applications and use streaming data to power real-time dashboards or machine learning algorithms. Or you can emit the data to other AWS services such as Amazon S3, Amazon EMR, and also AWS Lambda. Kinesis synchronously replicates your streaming data across 3 facilities in each AWS region and preserves your data for 24 hours, preventing data loss in case of application failure, individual machine failure, or even facility failure. Kinesis is a fully managed streaming data service. It allows for real-time data processing. With Kinesis, you can continuously collect data as it is generated and promptly react to critical information about your business and operations. Kinesis is highly scalable. The throughput of a Kinesis stream can scale up to terabytes per hour and from thousands to millions of put records per second. You can dynamically adjust the throughput of your stream at any time based on the volume of your input data. And data reads do not delete the data from Kinesis, which means you can replay the data in your stream for up to 24 hours. Kinesis allows you to have multiple Kinesis applications processing the same stream concurrently. For example, you can have one application running real-time analytics and the other sending data to Amazon S3 from the same stream. This makes Kinesis an ideal platform for moving data into your store or process engines like AWS Lambda. So moving to Lambda, AWS Lambda is a compute service that runs your code in response to events and automatically manages the compute resources for you, making it easy to build applications that respond quickly to new information. Lambda typically runs your code within milliseconds of an event. The service automatically manages the compute capacity for you and spins up the necessary infrastructure, deploys your code, and runs it for each event. Lambda functions are stateless with no affinity to underlying infrastructure, and each event is processed individually. This means that Lambda can rapidly launch thousands of copies of your function and run all of them in parallel as needed to scale to the rate of incoming events. Performance remains consistently high regardless of the frequency of events. For example, you can trigger an AWS Lambda function to automatically create a thumbnail when an image is uploaded to Amazon S3. You can set notifications when receive a message on Amazon SNS. You can verify address updates in an Amazon DynamoDB table, or you can process clickstream data in an Amazon Kinesis stream. Lambda functions can also be invoked directly from external sources, both synchronously and asynchronously, which makes it easy to build backend services to perform workloads such as image analysis, document transformation, and indexing. Lambda also enables you to perform data-driven auditing and analysis of your incoming data streams. For instance, you can watch for patterns such as an address, an IP address, or a specific key phrase, and trigger an alert based on that. Lambda allows users to focus on building powerful, dynamic, and modular applications in the cloud, while not distracting their productivity in the undifferentiated heavy lifting of managing infrastructure. Lambda automatically runs your code on high availability compute infrastructure and performs all the administration of underlying compute resources, including server and operating system maintenance, capacity provisioning, automatic scaling, code and security patch deployment, monitoring, and logging. As a developer, all you need to do is write the code. AWS Lambda runs your code only when needed, with no unnecessary costs. With Lambda, you don't need to build out and maintain a fleet of servers and then pay for the time that they sit and wait for their jobs to run. Instead, Lambda charges a low fee per request and for the time your code runs, making it very cost effective to build solutions that scale from one request to thousands of millions of requests per second. The nature of both of these services make them a good fit to use together. With Kinesis to capture your data and Lambda to process it. The combination of these two services opens a whole bunch of possibilities for users to run real-time streaming data processing workloads. For example, you can run audit checks on your IT application activity, whether on AWS or on your private environment, and alert your IT team on policy violations. You can pump your live metering records into a Kinesis stream and use Lambda to condense these before pushing to Amazon Redshift for longer-term storage and querying. You can collect log and event data from sources such as servers, desktops, mobile devices, and use Lambda to back up relevant pieces of these logs to Amazon S3. If you have a stream of financial data that you need to store or transaction orders that you need to process, you can feed these into a Kinesis stream and use Lambda to push them to RDS for storage or to an SQS queue for further processing. The incoming data stream doesn't need to be a single source. You can even ingest data from user click streams across thousands of servers in your fleet, or from millions of IoT devices deployed across the globe. Similarly, the output from Lambda may or may not be an AWS service. It could be your private endpoint for the backend which you have built, or even your custom application. So here I would like to run a quick walkthrough to demonstrate how easy it is to set up a Kinesis stream, attach multiple Lambda functions to it. One, to log the data from the Kinesis stream to CloudWatch logs, and the other to push data to Amazon SNS notifications. Now, I chose these two as examples to demonstrate that you can run multiple Lambda functions in parallel to respond to a single Kinesis stream. Lambda is not limited to only these two applications. Lambda functions have the Amazon SDK integrated into the code when you launch the function. This means you can access any of the AWS services from inside a Lambda function. You can also target different backend applications or private endpoints if you prefer. Here's the JS code, the JavaScript code for the two files we will be using. The first one iterates through all the records from the Kinesis stream. So as you see, there is a for each record. It decodes the data from the Kinesis stream, stores it in a payload, as the Kinesis data is base64 encoded, and then logs the decoded text to console.log, which within Lambda is directed to CloudWatch logs. The second function assumes only one Kinesis record per stream. As you can see in the second one, I have selected record 0 instead of for each record. It creates an SNS object with the message, the subject, and the topic earn, which we will walk through, and publishes that data to SNS. Note that in the second function, we have the context.succeed completion call inside the callback for the SNS publish call. Since SNS publish is an asynchronous call, we need to wait for that call to finish before exiting Lambda. So let's hope the demo gods favor us today and jump into the demo. The first step here is to create the Kinesis stream. So what we do is create a stream called demo Kinesis with a shard count set as 1. And I will walk through what these options mean through the webinar. So while we wait for the stream to be created, we will need the stream earn. So as the stream returns, it shows that it has created the stream. So since we need the Kinesis stream earn, we will do a describe stream, which will give us the earn of the stream which is created. So that's the first step. The second step, I will also create an Amazon SNS topic to which I will push the records. We do not need to create a CloudWatch log group over here. AWS Lambda automatically creates the CloudWatch log groups for each Lambda function that is executed. So I will do a quick create topic, which returns the topic earn. I take that topic earn and create a subscription so as to get that information from Amazon SNS. And as a notification endpoint, I use an email protocol to my email address. What they should do is it shows as subscription pending, which means I get information into my inbox, waiting for the subscription to succeed. I need to confirm this subscription before I could get the notifications here. So while this pops up, we will continue with the demo. The next you need to do is create an IAM role. So in Lambda needs a execution role here. With Kinesis, you do not need an invocation role, only an execution role. So I am calling a demo IAM role.json file. This file is in here, and all it does is it allows Lambda to assume the role which we have created. And the policy which I will be setting for that role is to allow Lambda to take actions on a Kinesis, on Amazon Logs, and Amazon SNS, since it needs to interact with all of these three services. So I go ahead and first create the role. Which gives me a role earn. I take that role earn and that role name and attach the policy document to that role. And in order to get the final ARN of the policy, we need a get role, which kind of describes what the final policy is. This shows that the policy has been created and has been attached. So then moving on, we need to create a AWS Lambda function. Now, AWS Lambda accepts zip files as an input. So I took the two JavaScript files, which I had described earlier, and created a zip file out of them. In this package, this is the only file which is contained. The AWS SDK is embedded into the code. You don't need to explicitly add that as a package. However, the current Lambda functions are written in Node, which means you can use any NPM packages and include those into your libraries, which would give you a very easy way of extending your library and calling in lots of pre-built applications and pre-built libraries into your Lambda functions. So for the first function, I do a create function. The create function takes what the function name should be. This is the Kinesis Cloud to CloudWatch logs function, which takes the zip file as an input, what role, the IAM role that you need to attach to it. Handler kind of indicates what the input to the function would be, what the first function to execute on entering the function is. And as I mentioned, the current runtime that we support is only node.js. This parameter will change as we add more languages to Lambda. The create function returns a function earn, which kind of shows that this function has been created. Similarly, I go ahead and create the second function. This function allows me to post the messages to an Amazon SNS event. Similarly, for this function, as you can see, I got the function earn, which means the function has been created. So from here, what we need to do is, now that the functions have been created, we need to associate these functions to the Kinesis stream that we created. You can associate functions to Amazon S3, DynamoDB streams, or Kinesis in the current application. As we add more data sources, you can also include those in the create source mapping call. Now, as you can see, the UUID is the unique identifier which Lambda returns, which uniquely identifies a mapping of a Lambda function to a source events, to an event source. A couple of the options which we call in here is the batch size. As you can see in here, I have set a batch size of 5. This means that this function will be invoked for every 5 records that you find in the Amazon Kinesis stream. A starting position of trim horizon indicates that you are always processing the first message which you have in the queue, and it maintains a record of where the stream is in terms of processing. Here you can see that there's no records processed because the stream that we created for Kinesis is currently empty. Similarly, let us map the second function to the same Kinesis stream. As you can see here, all of the other inputs are the same, except that now I am using the SNS function, and here I have set a batch size of 1. As you recollect, I had assumed in my code that I would be getting only 1 Kinesis record per Amazon SNS function, which is why in this case I selected a batch size of 1. It returned to me a UUID, which means that this mapping has been completed. Now, before I put records to the Kinesis stream, let me make sure I have the subscription topic. Looks like the subscription check hasn't come through yet. And I might not receive the SNS notifications in this case. But what I can see is still the CloudWatch log applications would still be ready for processing. Now, if I had received as a subscription topic notice, I would have been able to subscribe to that function and receive SNS notifications in my email for each of the records. But in here, since we do not have those, let us go ahead with the CloudWatch logs. So what I do is I call a command line function to add Kinesis records to the Kinesis stream. All this does is it adds demo Lambda messages to Kinesis. Now, you will be returned a sequence number, which indicates that each record has been put to the application. Now, so in this case, I simply put 10 demo messages to the Kinesis stream. And Lambda directly picks these off of Kinesis and starts processing them. Since there are 10 messages put here, I would have received 10 email notifications if SNS had gone through, but in this case, I can at least go through the CloudWatch logs because each Lambda function which executes will have done a post to log. So CloudWatch logs now allows you to filter log events. So you can search by a specific group name. As I mentioned, the group name will always be the same as the function name. And you can query for specific events and look for the message of the body and find the word payload because that is what I had appended each message with. Now this will quickly search through all the logs which are generated and show all the messages. Now Kinesis also also complies to ordered processing. So you can see that the messages that have been processed in the exact same order that they were received into the Kinesis stream. So in this demo, we saw how quick and easy it was to set up a Kinesis stream and attach multiple Lambda functions to it for parallel processing. And as I mentioned, these two are only sample applications. You can always add more Lambda functions to the same Kinesis stream and run parallel processing applications off of Kinesis and Lambda. Let us now talk a little bit about how things worked on the back end. The first thing to remember is that Kinesis streams are made of shards. Now we set a shard of size 1 in the application here. Each shard can ingest up to 1 Mbps of data at 1000 writes per second to Kinesis and can emit 2 Mbps of data at 5 reads per second from the Kinesis application or to AWS Lambda. This allows for a large fleet of devices to write directly to Kinesis, one record at a time, while the reader application pulling chunks of data off the Kinesis stream. Note that all data is stored for 24 hours, which means you can replay data inside of the 24-hour window as needed. A partition key is supplied by the producer and is used to distribute the put records across shards if you need to scale Kinesis across multiple shards. A unique sequence number is returned to the producer upon a successful put call. And this sequence number will be unique across the shards and across Kinesis streams. Therefore, you can trace this sequence number if you need to address a specific record or if you are looking for end-to-end mapping of records as they flow through your system. Internally, Lambda allocates one function to concurrently run per Kinesis shard. Lambda has a pull model for Kinesis, which means Kinesis is not pushing the data to Lambda. Lambda is pulling data from the Kinesis shards. So for each Kinesis shard that you have a Lambda function attached to for the stream, we set up a separate poller which pulls the shard for new data. When the poller finds that the Kinesis shard has enough data to cover for one batch of data that you want to pull, the poller will pull that data from the shard and pass it to the Lambda function for execution. Thus, increasing shards will cause more Lambda functions to be invoked concurrently. For a stream that has 5 shards, you will find 5 different Lambda functions being invoked concurrently. Each individual shard follows ordered processing. However, across different shards, you may find data which is out of order. So that is a application level intelligence which needs to be added to the function. Also, all Lambda functions will concurrently write data to your destination inputs and will scale automatically as you add as Kinesis shards. Let us talk of performance tuning Kinesis app as an event source. The first thing to remember is the batch size. Now, the batch size indicates the number of records that AWS Lambda will retrieve from Kinesis at the time of invoking your function. Increasing the batch size will cause fewer Lambda function invocations with more data per function, more number of records per function. Similarly, on the flip side, if you decrease the batch size, you will need higher TPS for reads, but then the Lambda function will finish much faster because they have fewer number of records. And this is a balance which you need to hit depending on what sort of application you are looking for. The balance is going to be between how many concurrent reads of Lambda you have and how many events per shard you want to choose. Remember that the TPS reads of our shards are limited, so often you might need to increase the number of shards you have to increase the TPS of Lambda functions being invoked concurrently. A second performance tuning option is the starting position. In the example, we set the starting position to trim horizon. This ensures ordered processing. Trim horizon indicates that the Lambda function will start reading the Kinesis stream at the start and keep a record of where it is in the processing of the Kinesis stream. The next invocation will always be in order, so you get a FIFO application built on your Kinesis stream. Other options for starting position are latest, which allows you to read the most recent data. This can be used to build LIFO applications where the timeliness of data is more important than the order of the data, and you would prefer to not process records which are older than a certain point, but you always want to process the latest information. There are a couple of best practices for creating Lambda functions that I would like to call out. The first choice you have is for memory. Now, Lambda allocates CPU and disk proportional to the memory which you configured on the function. Which means if you have CPU bound applications, increasing memory will make your code execute faster. Also, increasing memory allows for larger record sizes to be processed. Thus, the other benefit here is that, especially if you have a CPU bound application, since the code executes faster, you would consume fewer cycles of Lambda to complete your code. And because Lambda charges in small increments of 100 milliseconds, you often do not pay more for increasing the memory size on a Lambda function, since Lambda charges in terms of GB seconds. So a higher GB function, which executes for fewer seconds, would cost the same for you. The second function which you can set is the timeout. The timeout is currently limited to 60 seconds. Increasing the timeout allows for longer functions, which means you can process more number of records, you could do more activity per Lambda function, and you could even wait for asynchronous calls like the Amazon SNS call, which we saw in the demo. You can wait for specific activity to be completed on your client side before exiting the Lambda function. However, this also means that in case of errors, there is a longer wait before the function times out, and you get an identification of the error and are allowed to process it again. The next one is retries. For Kinesis, Lambda has an unlimited number of retries until the data on the Kinesis stream expires. Unlike a lot of other invocation methods such as Amazon S3 and external invokes, where Lambda retries only 3 times, for Kinesis we believe that the processing of the data is more important given Kinesis isn't a permanent data store. If Lambda is unable to process the data, you might lose the data on Kinesis, which is why in Lambda we have a concept of unlimited retries, where it'll wait for a specific action to be completed on your data stream before moving on to the next piece of data. This also enables you to ensure ordered processing for applications where order is necessary, because if Lambda skips over any functions or skips over any data inputs, then you might lose the order of your data. Last one to call out is the permission model. As I mentioned, Lambda pulls data from Kinesis. So for other functions which follow a push model, such as Amazon S3, you do not need an invocation role because there is no external service which is invoking Lambda. Here, Lambda pulls the data from Kinesis, which means Lambda is invoking itself. And you need only an execution role for the services which you will be touching inside your code, plus the execution role to pull data from the Kinesis stream. The last one I'd like to call out would be monitoring and debugging for Lambda functions. Lambda uses Amazon CloudWatch for both of these. Monitoring is available in Amazon CloudWatch metrics. We directly monitor activities such as invocation count, duration, error count, and throttle count on a per function basis. These metrics are stored in Amazon CloudWatch metrics, and the last 24 hours of metrics are presented within the Lambda console for you to view at a glance. For debugging, AWS Lambda uses the Amazon CloudWatch logs. So all the metrics that are monitored, plus all your custom logs, are logged to CloudWatch logs. CloudWatch logs data is not perishable. And as I mentioned, CloudWatch logs will create one logs group for each Lambda function. And then depending on your timestamp, it creates multiple log streams. We also record the actual RAM consumed inside CloudWatch logs. So you can use this information to fine tune your application to set it to the optimal amount of RAM, with which you invoke the function. And one thing I'd like to highlight is we recently announced the availability of searching through log events on CloudWatch logs, which means you can go through your log groups and search inside these log groups for specific errors, for specific payload information, or for any keyword or string. So in summary, Kinesis plus Lambda work well together for any streaming data processing use case. We have lots of customers running their real-time stream processing workloads using Kinesis plus Lambda today. with the common business requirement being the need to apply custom logic to process data being uploaded through a Kinesis stream. This includes processing tasks like client activity tracking, metrics generation, metrics processing, data cleansing, log filtering, and many, many more. The possibilities are limitless. We encourage you to try this out today and let us know how your experience was. 3 next steps I'd like to call out for everybody is to try out your first Kinesis stream. You can configure hundreds of thousands of data producers to continuously put data in an Amazon Kinesis stream. And you can ingest data such as website click streams, application logs, or even social media feeds. We also invite you to create and test your first Lambda function. With AWS Lambda, there are no new languages, tools, or frameworks to learn. You can use any third-party library or even native ones. And remember, the first 1 million requests each month are on us. And finally, I'd like to invite everybody to use AWS Lambda to process Kinesis streams. These two services just go well with each other. There's no infrastructure to manage. And as you saw in the demo, we can set up a real-time analytics stream in minutes. So here we shall take a quick 2-minute break, after which I will be opening up the session for live Q&A.